Welcome back, Generals, to another Let's Fix Generals 0 to make the best game ever. And last session, we looked a bit here at those vtables and type info. And we need to understand how this comes to be. Sorry. So, hold on. Also, how do we know that this is a public inheritance and not a private one or a protected one? We probably don't, because it's it is something that the final program doesn't need to preserve. It's just something that helps the compiler to throw some compiler errors. Yeah, but not sure. So maybe all inheritance here will always be public. There's not ever a protected one or private one. Yeah. So the question is, also the pure virtual functions we need to look at. Yeah. Yeah, it's not yet clear to me how this works. Reference to type's name. Parent's type's name. Ah. I see. So this here, if we search this here, then it's not found. Okay, how do we get here? Here, this one, I think. This one. Okay, there we go. So type info for poisoned behavior module data. Yeah. Type info for this. Okay. And so this refers to this type info for poisoned behavior. And here it says vtable. It refers to a vtable here. Yeah. And then next it refers to type info name. And then the next it refers to its parent's type name. And then so from this parent, if you look into this parent, then you know that this parent's parent is where do we see here? Here. Then you know, so this is this type, and you know that this is a parent of this one, and then this is a parent of this one, and so on, right? And snapshot is the most outer base class, right? Why is this written like this here? Ah. Okay, so this is a simple example, but this one seems to be a more complicated one. So, propaganda tower behavior. And then what's going on here? What is going on here? Type info name, type's name. Reference to type's name. Reference to type's name. And then there's a 0 attribute. And then there's a 2 count of base classes. Okay, count of base classes. So this is the first one. And this is the second one here, down here. Count of base classes. And then it says this one. And then it says 2. What does that stand for? Oof. Okay, let's ask ChatGPT on this one to help us understand. Actually, before we do that, let's look a bit more. So I understand this here. This is simple enough. Here, it has a 0, and it's not clear to me what this 0 is. Here it says, it helps us understanding this is a count of base classes. Okay. Here, 1 and 2. And then here, base class attributes 2. What does this 2 stand for? And what does this stand for? Okay, we need to ask ChatGPT for some help, maybe. Okay. Okay. Given the following type info. Is it type info? me see. Type info, yeah. Given the following type info of a class, what do these attributes, what do these attribute values, attribute and base class attributes values stand for? Given the following type info representation in of EDR of a class, what do these attribute and base class attributes values stand for? Let's see. In this context, the attributes and base class attributes are part of the RTTI implementation and used to describe class relationships, particularly for handling polymorphism in a multiple or virtual inheritance hierarchy. The value is 0, which typically means the class has no special attributes. This field can encode flags that describe the nature of the type, whether it is abstract, whether it uses virtual inheritance, other implementation-defined properties depending on the compiler. Okay. The lack of attributes suggests propaganda tar behavior is a straightforward class with no special RTTI requirements. 2 immediate base classes. Update module and this. Base class type descriptor. Each base class is described by its own RTTI type B descriptor. These descriptors point to the type infrastructure of the respective base class. The offsets this and this refer to the type descriptors of this and this. Yeah. Base class attributes. The base class attributes describe how each base class relates to the derived class. Base class attributes describe how each base class relates to the derived class. Inheritance times. Whether the base class is virtually or non-virtually inherited, whether the base class is accessible. Oh, okay, so there it is. Aha. Offset. So 2, the value of 2 indicates update module is non-virtual. Aha. It is publicly inherited. It resides at offset 0, 0 within the derived class object layout. So the first position. Die object interface, the value of this or this can be decoded as public non-virtual inheritance. Resides at offset 20. Aha. Okay, so the lower, I guess the lower 1 byte here is to set if it's public, private, non-virtual, and so on. And then the upper bits, upper 24 bits, maybe they will say this key takeaways. Okay, provide metadata about the type. Okay, so the RTTI is a bit more complex than I thought. Is there a RTTI header or library that takes care of interpreting RTTI data, that can take care of interpreting RTTI data consistently, correctly. There isn't a direct C++ standard library. Okay. However, there are libraries, headers, and tools that can assist. Okay. Provide utilities for working with it. Additionally, certain compilers have documentation for APIs for interacting with the RTTI implementations. Most compilers have their own RTTI format. GCC and Clang use. Yeah, we have seen this, right? We have seen that here. There. CXX ABI version 1. Okay. You can include cxxabi.h. Let's look it up. cxxabi.h. Here, libstd. Okay. That doesn't seem to help us. What about LLVM cxxabi? Let's search for the same version. ABI version 1, v1. Clang. There we go. Implement cxxabi specific semantics. Okay, I don't understand. These functions are not what I expected. Okay. Writing a custom RTTI parser. Yeah, but this would require access. If you need low-level RTTI parsing, use this. Or write custom parsers. For higher-level reflection and type introspection. Okay. LLVM Clang tools. Clang can be extended to analyze RTTI data. Okay, so and this is interesting here. I wonder then what this tells us here. Class type info. Let's ask: will cxxabi.h work on Windows with MSVC? No. Okay. Okay, so this makes it very specific to GCC Clang. How can we use LLVM to inspect cxxabi RTTI information? Yes. Read objects. Object dump. LVM object file. I see. Okay. Basic RTTI. So that's 3 types. And I think we have seen this. Let's look at this. Yeah, here we have all 3. Class type info. So that's, and there's also an enum type info. Oh, okay, cool. enum type info. vtable. Yeah. Enum class. So this SI is a single inheritance, and this is multiple inheritance. This probably means virtual single inheritance, and this is virtual multiple inheritance. Class type info. Okay, interesting. Okay, I think, yeah, it would certainly help to use an established parser to understand this instead of rolling our own. Yeah, and if LLVM already has it, then we should certainly use it. Yeah. Use LLVM to parse these structures directly. Use LLVM read object or LLVM object dump to inspect RTTI sections. And so, okay, this is a good start. And can you clarify this? Can you elaborate a bit more on process RTT data here? Perhaps give some example. Certainly. Let's see. Function to decode a null terminated C++ ABI string. Decode type information. Huh? Iterate over possible RTTI entries. Type info. Analyze RTTI. Process RTTI section. Okay. Expected output. Type info for that. For that. Okay. Example structure for this const base. VMI class info type. We have seen this. Flags. Base count, number of base classes. Base classes array. Base classes array. Okay, that is unexpected though, because here it's different. Here we have a pointer to this type info for this, and then we have attributes for it as well. So this doesn't seem to be like this. I don't know, because here it's just one pointer, but there should still be some flags, right? Yeah. Demangle names, yeah, handle multiple sections. Could you generate an example for using the class for certainly. Aha, that looks more like what I expected. Yeah, this looks like it's. So we first have type info flag space count, and then we have a array of another pointer and the flags. Yeah, that matches our observation. Good. Attributes of the class, such as whether it virtual bases, number of base classes, decoding RTTI. Reinterpret cars. Okay. Okay. So this. Can you give the. Can you show how the same would be done with LLVM instead of CXX-ABI? Let's see. Okay, so here RTTI entry, reinterpret cast. Yeah. Yeah, and I guess this one comes from some of these. Yeah. Base count, demangle type name. Base count, base classes. Okay, there we go. Okay. Yeah. This makes absolutely sense. Yeah. Okay. Now the question is, can we get this in a small form? So the question is, can we get hands on this one here without using LLVM? Because the demangler we currently have is also without LLVM. It's just borrowed from LLVM. So the one we got was XLLVM demangler, right? This guy. Wonder if there also is a repositories. LLVM. No, he only has a demangler here. Let's see what other thing. Yeah, maybe we need to. Yeah, maybe we should get the original LLVM. Yeah. If it's easy, I think we tried this and it was not that easy. I can't recall. Let's open a new chat here. Can we add LLVM to a project with CMake? Yes. Okay, I don't want to do this. Find LLVM package. Can we add LLVM LLVM can we add LLVM without pre-building it and instead make it part of the CMake project build? Clone, yes. Update, modify to configure, okay. Link libraries, LLVM, okay. External project add. Okay. Okay, I guess you can try this then. I don't care about the build time. Yeah, I think this is the best approach. Well, yeah. Yeah, I think here we use then this fetch thingy, declare, fetch, whatever, make available. Good, then we try to do that. Okay, so the plan is for the next session, we create a new project. We add leaf and LLVM. Maybe we don't need leaf. Maybe we could just use LLVM from start to finish. We have the demangler in LLVM. We have the RTTI parser in LLVM. And I think that's all we really need to get all the info we want. The rest we write ourselves. Yeah, to build structures of classes, functions, files, and so on. And yeah, I think we can get it to work. Collect all data that we can get hands on. Yeah. Now there's one more thing. The enum type info. I'm curious about this one. Enum type info. Yeah, here. So for example, this one. What is this? Enum type info. Type info for error code. Okay, I guess there will be also RTTI class that interprets it, and then we can take a look at it. Okay. Okay, I think we have like a basic understanding. Now, there's still probably implementation details that we need to discover, but we can all do this while coding. But we have, I think we have a pretty good understanding of how to get the data we want for the most part. Yeah. 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 We should be able to know what is a class. I do wonder, how do we know if something is a struct or a class? That I have not yet seen. How do we know that? Let's ask here. Does RTTI give information about an object being a class or a struct? Typically, it does not directly distinguish whether an object is a class or a struct. The reason is that from the perspective of RTT, both class and structs are treated the same. Yeah. Syntactic. It doesn't inherently include information about whether a type is a class or struct. Okay. Okay. Okay, I see. Okay, then let's ask something else. Does okay, This is another question. In MachO, without dwarf data, can but with SimTab, data, can we check, or can we, does it provide in a MachO executable without dwarf data but with SimTab data, does it provide information about the publicness, about the visibility of a class method? Public, protected, private. Visibility. The information about visibility is generally not included. Oh, okay. The SimTab section in a MachO file contains the symbol table, the name of the function or variable, SimTab does not typically provide visibility information. Compile time constructs and they control how symbols are accessed within the source code. At a binary level, the compiled code doesn't retain explicit information about these access control keywords. But then why would it retain this information about public, protected, private inheritance? Because that's also just a compile time thing, no? I'm confused. Symbol visibility. Oh, okay. Well, sorry for mixing up. In the absence of dwarf debug data, the SimTab will typically include symbols for the names of the class methods and member functions, but it won't explicitly mark them as public. That's unfortunate. Well, it's not the end of the world. We just make everything public then. These methods will usually be public unless otherwise stated by the symbols binding. Huh. Global symbols, methods, or function are globally accessible. Local symbols, methods that are private or protected within a class may be localized. What does that mean? But again, SimTab won't explicitly mark them with the access level. The symbol's locality within the binary, whether it's local to the specific translation unit or globally accessible, is the main piece of information. If you're interested in access specifier for class method, that data is typically included in dwarf, which we don't have. Okay. Okay, no, then we can't do that. Does not provide explicit information. Okay, good. Then yeah, then I think we have a good overview. We can build all the files. We can build includes. We can build all the classes without differentiating between structs and classes. And I think we just settle on classes. Public functions, external functions, and so on, and class methods with virtual functions, with inheritance. We haven't looked at pure virtual functions yet, but yeah, I guess we don't need to look at this right now. We will get to this when we look at the RTTI. Yeah, it's a pure virtual. Yeah. Okay. Yeah. Yeah. So at the end, we will have class skeletons with all the methods, all the inheritance, all the virtual functions, the overrides. We won't have function return types, so these we will have to add a placeholder macro. I guess we just make them all void to begin with. Yeah. With a macro, so it can easily be identified that this is a placeholder. And it needs to be confirmed first, yeah. And then, yeah, we then generate all the headers with the declarations, all the CPPs with the definitions, which are then empty, nothing inside. Nothing inside, aka like just the functions, but no function body. Unless they are statics, then we can put the statics in there, but that's it. What else? That's it. And of course, single functions here and there. Yeah. Yeah. Static. There still is a question about like more complex static variables, the initializer values. Yeah, I don't know. I guess we will see that later. Yeah. Okay, anything else? No, I think we have the biggest things in mind. Now, obviously, there will be a lot of implementation details that we need to discover as we implement this. But for the most part, I have a general idea of how we do this. So basically, we first have a parsing pass, either with LLVM or through Leaf. Probably multiple passes over the symbols. Get the data and then organize it into new data structures that give a nice view over files, classes, methods, statics. Yeah. And then an inheritance. And then, yeah, once we have all this collected and we are happy with it, then we will have a generator that then uses this data to generate the outputs. Yeah. Okay. Good. What's the time? 55. Yeah. Good. Then I will take a break here. We have a plan. Let me put an update here in the chat. I looked at the RTTI and have a understanding of it. I looked at the RTTI, have a understanding of it. In LLVM, there are structs that help work with that. Looked at the RTTI data, have an understanding of. In the LLVM, there are structs that help work with that. I now have a good enough understanding of all the high level, for the major data points, and I think I can start work on collecting all the various data we need for code generation. I think it is possible to implement. Okay, good. So we have an understanding. I think it is possible to implement, so we can start work on it. Yeah, will just be some labor, but yeah, it has to be done. It has to be done. Good. Then yeah, I will take a break here, and then I wish you a great day or night until next time. Goodbye. Next session we will start with the new project. Yeah.